But I can go back to our drivers, so it's kind of nice.
Oh shoot, I have to.
If you
So
take,
chapter 8.
If you, that's all I'm gonna do
if you take 432,
So Kevin was really worried about it. And he
please,
finished
because you will, there's 20 things you gotta like
yeah,
download.
every driver.
I gotta make it to this
chapter
class
8 's
right
gonna-
before I even sign up.
You completed all the drivers.
That's why I'm at right now.
Yeah, I don't know what he's gonna ask for him.
He's just asking for number 8. He's asked for number 8, well, he has their
No
supposed to.
problem. Okay. Alright.
Yeah. Especially because there's multiple parties. I get sick. So if you really want to see what they're around. That would be a shame, but it was not before.
I double check it all the time.
You changed it 4 times since you've been sitting here.
Well, yeah, I wanna make sure I'm not missing out on, valuable.
Make sure it's not pointing at the wrong board.
It's not pointing this way, it's pointing backwards. Wow, the sky.
You have to be recording the background the whole time, the back seat.
Oh, Brady's in the bathroom.
Brady's here.
Okay,
We got this
so
one.
Justin, Chase, I saw you, Garcia, Brady, you said to see Kevin, Kelvin, Dalton, I saw you, Ryan, Jeremiah,
Here.
I think so.
Ethan, Aliso,
Here.
Mary, Shane, Jake, Zander, Andrew, Tony, Leon,
Send each girlfriend should be about
Earlier than normal.
Typically,
As they start to solve
problems and all,
Unless he teaches.
screenshot at once, that way it's got a whole.
nothing going on.
Because the way I got it right now, I've got it spanned across
That's how I
like
test mine.
both
We're in a circle.
screens. I seem to control it up on the computer, like I got my little iPad that I use, and I see
is everything?
everything in there.
I just want to apologize. Is it Paul Rob? Would like to see him now. Is he here now?
I think he is. I think he's on.
You think he's on?
Yeah.
I sit in the very back and I can see like code on the screen here, there.
Was there
I think he's just going down there.
Handy, man.
program something?
No, it just, I didn't know how to look for it on Friday and how to know.
Yeah. Shit, my life was easy.
Exactly, people are looking for no different where they leave.
Yeah, but you
I mean, like, with the law, like, but you don't simplify it down.
It's hard just to answer.
That's great.
You can't simplify it down if you can have everyone just with the board.
Oh, yeah.
Now they're wanting to back. Now they're wanting to just
Like, I didn't, I always figured from the
Okay, everybody submitted assignments?
Yes, sir.
Yes, sir.
Question 1. We want to solve this problem in Laplace. Okay? First, we need to translate to the Laplace. When we want to translate to the Laplace, what is the first step? When you want to transfer to the Laplace, what is the first step?
Find initial values.
Initial values. Actual value. Okay. For initial value, we have this switch and this voltage. Together means what? Andrew? A switch with a voltage source together means what? It's not the case here, okay? In general, I'm talking. It's a unit function together. It is not the case here because it is opposite. But in general, when you see a voltage source, current source, whatever, with a switch together means a unit. That's the definition of unit function. But it's not the case here. Every step you sketch the circuit again and again to avoid confusion. So the circuit before T0, I need it for initial values. Okay? I have a voltage source 12 volt, a resistor. Before T0, the switch is closed. And something like this. Correct? Then it is
Don't you have
3K, 4K, what?
You have to open the capacitor.
Wait a second. This is the circuit for T. We assume, repeat this step, okay? I assume that before T0, long time passed. When long time passed, Shane, what's gonna happen to the capacitor?
The capacitor is gonna be fully charged and then it will become an open circuit.
Open circuit. So, then the voltage here is what voltage? VC0 minus, which gonna be equal to 0 plus. What is this voltage? It is the voltage at this node. And to find the voltage at this node is a fully resistive circuit. The voltage here is a voltage division technique we can use and find. VC0 minus equals to 12 by, the resistance here is 6K, am I right? Over 6K plus 3K. It's gonna be 6 over 9, it's gonna be 1 over 3. It's gonna be how much? Why 8?
It should be 3K instead of 6K at the top.
Oh, it's a 2 bar, yes. 8 volt. Correct? Now we have initial value. For T bigger than 0, what's gonna happen to the circuit? The switch is open. I open and remove it. For T bigger than 0, we have a capacitor, a voltage source, and we transfer everything in Laplace. C gonna be 1 over 100 macro S, 4K, 2K, we don't care. This gonna be what, 8 over S, I guess? Or initial value 20. So, we don't need it. It is in Laplace, we don't need to be worried about the transient, that table. We write 1 KVL here and we're done. Then minus 8 over S, we call it I. Minus 8 over S, minus 1 over 100 macro S by the current. Why is that minus? It's gonna be plus impedance. Plus this together gonna be 6K by I equals 0. From here I can find that I gonna be 8 what we need is not exactly I. We need the V out. V out is I by 2K. I multiply everything by 2K. 2K. Then it's gonna be VO. And then multiply everything by S. VO gonna be 16K over 6KS plus 1 over 100 macro, which can be 0.1 milli. Okay, then it's gonna be kind of 1 over this is gonna be, this milli is gonna be K, I need 1 10K. So instead of 1 over 100 also I can put 10K. I have K here, K here, K here, I can ignore all of them, or cancel them, all cancels. I will divide it by 6, yes,
Should be 10K over S.
I multiply this one by S.
Oh,
and
yeah,
this.
okay.
16 over 6 over S plus 10 over 6. VOT gonna be what? E to the power of negative 10 over 6T. Actually, over 6 multiple and ut. New question. Question number 2. Again, Laplace domain. We want to transfer it to the Laplace, we have to find initial value. The circuit at T before 0 is what? Capacitor is open circuit, inductor is short circuit. Then my circuit is gonna be here, it's gonna be plus minus VC0 minus. It's coming here, 6 volts. The switch is closed. Pay attention to the direction, and this one also is a short circuit, and this current is going to be IL0 minus. The target now is to find is to find this voltage in this circuit and this current. These are initial values we are looking for. Correct? Here is open circuit. Then this current is the current in this resistor as well. There's one current here. This is the same current, IL0 minus, same. Now I'm gonna write a KVL here to find 2 KVL. 1 KVL here to find this VC, 1 KVL here to find this. 1 KVL here, 1 KVL here. For this KVL, I need the current here. Then I solve this KVL first. It's gonna be plus 24. The current voltage is gonna be plus 4 IL. I know that. Let me try it. And this is also 4 4/8. Correct? Which is minus 3. This is the first initial value. For the second caveat, it is minus 6 plus VC 0 minus. Then I'm coming this way, it is the current, actual current is the other way. So we consider it as it is. I say plus 4 by minus 3, that current, minus 24 equals 0. So, did I?
It would be
It would-
negative 3.
Yeah, because if you're assuming that the floor in the first one.
I'm writing everything based on this current research.
You would get a completely different answer if you did it that way, though. Because you would get negative.
Okay, let's review that. Minus 6
Plus,
plus VC.
and then it would be minus,
Why?
because for the first one, we assumed it was plus from the bottom, when we were writing the first one for
Forget
IL.
this one. Assume it is I1. Let's write it based on this I1. Am I right? Based on that I1, I say plus
So-
4 I1 minus 24 equals.
If you were,
Up to here, you agree? It's gonna be.
so would the sign on the 3 change? The sign on the 3 would change, it would be positive 3 because the negative 3 is going this way and then the I1 is coming this way, and so the 3 would be positive.
So right now, you agree with this, I will explain later.
But I think I1 should be positive 3 if we're changing the direction.
So wait a second. Right now, it is correct or not? I'm not saying you are wrong, okay? Maybe I wanna find my problem.
Well, I left the.
Don't give me the right answer, I know right answer, that's fine.
I did, the left loop as A and the right loop as B, and I wrote my equation as -6 plus VC 0
You are
plus
correct,
4
I am
negative
wrong,
3.
just wait me, let me find what is wrong, why I made a mistake, that is important learning process, okay? I'm gonna take advantage of this, where I made a mistake. So far it's okay? I1, this is I1. Just follow with me. Okay. Is this okay or not?
Yeah.
Okay, so I wanna find a problem. And you are sure that we calculated this current correctly with this direction.
Mhm.
I know I'm wrong, but I wanna see everybody get why I'm wrong. So, this equation correct, this value is correct. What is the relationship between I1 and IL?
I1 is negative I1.
I1, not this one. I1 equals negative IL, correct. Then, what is this value, IL minus? Minus T. I know I'm right, but I want everybody see why I'm wrong, or how to fix if you are wrong. Thank you for mentioning that. Now you're right. Thank you. But the approach of finding the mistake and or double checking things is important. Always do that step by step because it's gonna be confusing. Okay. Based on that equation, this is gonna be 12, and you cancel 12, here is gonna be left minus 12 minus 18. VC 0 is 18. Right? Okay. Next step, t bigger than 0, Laplace circuit. For that one, this switch gonna be open. We don't have these two. We calculate why nobody asked, why I consider this current in this direction or this direction. Why you didn't ask that? How you find that the direction I put plus here minus here?
Just assume. Just because voltage source.
So why it is, why I consider this way, not the other way?
Because you made the direction of I1 clockwise, so the direction pointing in is going to be positive and out is going to be negative.
No,
You just made an assumption.
because it doesn't matter. If I consider the other way, this voltage was negative. Like here, I consider this way, but actually it is not correct. It's the other way because it is negative. Yes.
So if you assumed that your VC of 0 was the other way, like, do you have to assume consistency between the two, or, like if you said that IL of 0 was going up instead of down on that branch, and didn't change the direction of VC, would that change your answer?
Eventually, when you want to apply it, you apply it based on this direction and consider this negative. Eventually, it is correct.
Okay.
You can correct it here. Consider the other way. You can correct it here. Consider the other way and make this negative. But you don't have to involve yourself to this kind of things. Okay, what's left is gonna be voltage source and a capacitor. Because it's gonna be one loop, I consider this as a voltage source like this. 4 ohm. This capacitor is gonna be what? 3/16 is gonna be 16/3s. 4 is 4. The inductor, because I don't want to add loop, I consider the voltage source. For this voltage source, we assume the current in that direction. Here I consider it like that. It was originally like that when you have a current in this way. No, it was other way. Sorry. Just check that table in the slide. And we have this. So what is the value for this? It was L, I, L?
It's gonna be negative L times I, but I initial.
Negative L?
In the PowerPoint, the equation for like, when you're doing the inductor and the voltage source is gonna be SL, IS. So it's gonna be your inductor minus L times your initial I.
In the formula we have negative, forget this negative sign.
Yeah, in the formula on the PowerPoint, it was negative. That's what I.
Maybe that they consider the direction other way and they put it, because I don't remember any negative. Can you double check and show me? Do you have a slide?
Yeah.
It is LIL0. What did you write? In your calculation.
That's what I wrote.
That's what I wrote.
This is
But
It's right.
also with the direction of the current I set.
For the-
Okay.
I don't know. Go to the
you're calculating it out, I use.
Here, just like margin. What's it there? Yes, yes, under it.
It's just a negative.
No negative,
But in the equation, when you're
because
calculating out
that
the
negative
voltage.
considered because of the direction of this.
Yeah,
We applied that negative here. With this polarity, it is plus.
yeah.
Am I right?
Mhm.
Okay.
But, yeah, I used the equation before I made the circuit.
Forget the equation, that was the process of learning. Just right now, with this direction, it is positive. So, L is how much? 2 over 3. 2 over 3 by minus 3. It's gonna be minus 2. This minus 2 gonna be you can change the polarity, put plus here, minus here, and say 2, doesn't matter. For this one, it is a 6. Again, because we have a switch, suddenly everything changed. For that 6, we can say 6 over S. What is left? This is 2 over 3 S. Now we have one loop. What I forgot?
The 18 volts.
Oh, thank you. This is how much? 18 over S, am I right?
Yes.
Then what is the target?
IT.
IT. So that is IT, or in this case, say IS. We find IS, one loop, and we can find IT. In this case, I can put all voltage sources together and all impedances together, Ohm's law. If you write a KVL, it's gonna be same thing. It is the KVL simplified KVL. It's gonna be 6 over S minus 18 over S plus minus 2 is minus 2. Then we have 4 plus 16 over 3S and 2 over 3 I multiply S for both denominator and numerator. Then IS gonna be minus 12 plus 2S, or let's put it in the right order. Minus 2S plus minus 12. This is gonna be 4S. Or let me write it in this way. 2 over 3S, 2 plus 4S plus 16 over 3. I try to simplify that. This gonna be minus S plus 6. I remove a 2, take the 2 here. This gonna be 2, this gonna be 8. Okay, I multiply everything by 3 also, then this gonna be minus 3, this gonna be 5, this gonna be 6, this gonna be 8. Something like this, correct? You calculated the same thing? Correct me, okay? In that discussion, I didn't want to discourage you to not correct me. I wanted to let me know where I made a mistake. Okay. Minus 2 was here. The poles here, minus 3 S plus 6 this is S plus. Okay, what is the four?
S plus 2 and S plus 4.
2 and 4. So it's very easy, am I right, for the rest? You can easily calculate. The I T gonna be something like that. Let's say K1, easily you can calculate that, e to the power of minus 2t plus the K2 e to the power of minus 4t. UT, K1 and K2 can be easily calculated. Was easy, am I right?
Yeah.
These are also same time. What is when the next class gonna be start? You know, 11 or something? Okay, let's see how much we can solve. We couldn't solve all next week. Yes. Before, at the beginning of the class, I will cover the rest. We have a lot of time.
Do we have to be here at 9 next week as well?
Let's see, no.
Okay.
But the following week, yes. Because I wanna finish the assignment 4. And today, one of you at least send me one email if I forgot to put the assignment 4 on Canvas. Or I already did it, maybe.
You uploaded the assignment, but you didn't upload the file for it, I don't think.
Assignment 4,
You-
I didn't put the file.
No, you didn't put the
There's no
file.
You just
Just
uploaded
remind me,
the-
I will do that. So, again here, the switch is closed. This gonna be short circuit, this gonna be open circuit. VC0 minus, and for this one, the direction is given I, L, generally it says I is 0 minus. There is no current here. For TV4, 0. Switch is closed. And when we have switch, we can consider all of these are 20 UT, 30 UT. Unless, like the other problem is given. Because it's a switching. Changes happen via switching, like a step function. What is the voltage? It's better we calculate the current here. What I can realize quickly is that I have 2 resistors and I have a bigger voltage than this here. The current gonna be the other way. What's gonna be the current? The differential voltage over I is gonna be minus 30 plus 20 over 5 plus 1. This is I 0 minus. Correct? Is that a minus 1? So if we know the minus 1, what's gonna be the voltage? This is open circuit, we need the voltage at this node. So, same resistor, this is 20, this is 30. What is the voltage here? This is 25. you write the cable is gonna be the same. So from here, we have I 0 minus is -1, B, C 0 minus is, what should I say, 20. For T bigger than 0, this is open. This is open, we don't have anything here. Forget it. Our circle is here. The voltage source gonna be a voltage source plus this is gonna be 12 over S. 5 is 5, it is 2S. And the voltage source with this direction gonna be what? We said L with minus 2 because of the L, minus 1 because of the current. And is there anything else? Oh, this voltage source is 25 over S. And this is 20 over S, which is in the circuit. Doesn't matter if it is close to that or not. It is for after T. Now we want to find this current, which is IS, or equivalent to this current that we are looking. So it's gonna be again minus 20 over S, minus 2 is going to plus 2, plus 25 over S, plus all resistance 5N, plus 2S, and plus 12 over S equals 0 based on the, IS equals 0. Then is gonna be, this goes other side. First of all, we can cancel this one, is gonna be plus 5 over S, is gonna be minus 5 over S, minus 2 over this 10 plus 2S plus 12 over S. So now I multiply everything by S, then this gonna be something like this. This is gonna be 10S, this is gonna be S2, and this is gonna be cancelled. IS, if I divide everything by this 2 is gonna be also minus S plus 2.5, and this is gonna be S2 plus 5S, 5 divided by 2 is gonna be plus 6. Correct? Same thing calculated? Okay, this is gonna be S plus 1 S plus 5, is that correct?
S plus 3 and S plus 2.
Okay, thank you. 1, it's gonna be 6, okay. That's opposite. If it was 6 and 5, it was 1 and 2. This is super easy, right? Okay, next question. What about this? Rayan, you came late. What is
So,
easy about that?
there is no transient circuit, you just need to make equation
There is
is,
transient circuit.
like, here it's 12 UT, so it's not, we can just say 12 over S.
Okay, that's of course, but something else that is very nice about this circuit. Already you tell me.
There's no switch.
UT is a switch in series with this.
Oh.
We can ignore one important step.
The initial values.
Initial values, we don't need to calculate it. But it's gonna be, there is no other source. Then it is very easy to convert it to Laplace. It is 2, it is 2 over S, it is S, it is 6 over S. What do you want? This current. Write one KVL, one KCL, whatever you want. You calculate that. 2 KVL definitely is the solution. You can write one KCL also. Superposition. Even source transformation you can do from this side. You convert these two, then this can be parallel with this. Simplify that, return it back to the Thevenin version, and gonna be one loop, 2 voltage source, 2 inputs. Just assume that if imagine something like that, I'm gonna write the final KVL. I'm gonna practice to see if I can do it or not. This is gonna be I1. Then in that I1, this voltage source is in this direction, goes to the other side, then positive 12 over S. This voltage source, anyway, the direction is the other way, this way, then it goes to the other side, definitely is gonna be plus. But what's gonna be the value of that? I need to convert it to the current. It's gonna be voltage over voltage divided by the impedance, which is 2 over S. Then this is gonna be 3, the current. And that current must be multiplied with the parallel of this. I said 3 multiplied with S in parallel with 2 over S. This is gonna be the voltage. Divided by the impedance of the loop, which is 2 plus this parallel value. This is your IS. I shouldn't do that, am I? It was a little bit confusing. Now everybody got that? What I did?
Yeah.
Okay, let me do the process. That's why I'm saying everything you do, repeat these sketches of the circuit step by step. I did, for the first step, I did this. I put these two a Norton version of this Thevenin circuit. I calculated this was 3, these two also same to S, what? 2 over S. Up to here is clear, am I right? These two I call it S parallel with 2 over S, fine? Next step was plus minus 2 that package of parallel things with a voltage source. What is the voltage value? 3 by this impedance. 3 by S in parallel with 2 over S. And this is S, it is 2 over. Now, 1 kVL, the current gonna be sum of these voltages over the impedance. This is 2. So this was 12 over. Clear now? Any question? You could write 2 kVL, you could write KCL, whatever, superposition. But I found that this maybe is fast. Who solved it in this way? Then it is good that I gave you this example. So you don't, do you have any problem with this part? Simplify it. You're all expert then. Good
Yes.
class. So. Next question. What should we do? What is beautiful about it?
No initial conditions.
Who said that?
I don't know.
Hey,
That's correct. This is the input. The only input is here. At the beginning it is like UT. There is nothing before that, no initial condition. That is, make it easy. No initial condition, I'm gonna transfer the circuit to Laplace. What is that? It is very hard. This is gonna be 1 over S. This is 2, 3, 1. This is gonna be VI S. And this is gonna be VOS. The target is to find VOS or VOT actually. The only problem is this. What is this? So, given here, let's focus on the right, on the time domain version of that. In time domain version, VIT is what?
6 for 0 1.
6 UT minus 6. Everybody agree with this? It's gonna be 6 over S minus 6 over S plus 1. No. Over 6 what?
E to the negative S.
Or you can say 6 over S, 1 is the power of minus S. Doesn't matter. You put this value there. Then you find V out. KVL, KCL, superposition. Oh, voltage division we can have. Yeah, I mean, some step before that you need to do, but make it more confusing. Or source transformation. Which one is easiest, Aliso? How did you solve? You came here, I have to ask questions. It means that you are very interested. In the first
I was
round.
looking in the book and what he did on the problem that was kind of similar when he basically add these in parallel or add these in
That is his solution. I'm gonna write one case here. My approach is one case here. Jake, what is the voltage here based on my target parameter? Everybody, what is the voltage at this node based on my target VO?
The VI of S times the parallel of,
No. What is the current here?
VO of S divided by one.
VO, I just say VO because it's easier. VO over 1. This current goes to this, so there is no current, right? This VO ampere pass through this 3 ohms resistor as well. The voltage here is current multiplied with the impedance from this reference. It's gonna be 4 VO. Correct? Everybody agree? Now I'm gonna write one KCL there. I assume the current going this way, and this way, 3 current. The first current is gonna be plus, the voltage is 4 VO over 1 plus 1 over S impedance. Agree? That's the current on that left branch. The current for the middle branch is plus 4 VO minus VI, am I right? Divided by 2. Plus, what is the last current? VO, you already calculated. VO. I have one equation, one unknown parameter. For this VI, the value is 6 over S, 1 minus e to the power of minus S. It is given. You only need to extract VO from this equation. This VI over 2, I can take it to the other side, then I will have VO 4 over 1 plus 1 over S. This 4 over 2 is going to be plus 2. And this 1 plus 1. Other side, this minus over 2 is going to be plus over 2. And if you divide this function, this part with 2 is going to be 3. It's going to be plus 3 over S 1 minus e to the power of minus S. Then for this equation, I multiply everything by S. Only this part is going to be S plus S1. A little bit simpler. These two together is going to be 3. I need to divide both sides by this value. It's going to be VO. I can add S. It's going to be 3 over S. 1 e to the power of minus S. Over 4 S plus 1 plus 3. So I can multiply everything with 1S. I'm gonna simplify that. This gonna cancel, this gonna be S2, this gonna be S. Okay, one step better, and then multiply everything with S plus 1. It's gonna be 3S plus 1 multiplied with 1 minus e to the power of minus S over 4S2 plus 3S by S plus 1. Here, And this gonna be also 3 S2, this gonna be 7 S2. And it's gonna be 3 S left. This is left. I multiply this part of the function by 1 and this one. Then I will have this 3s plus 1. I take s out, it's gonna be s, looks easier, s plus 3, you'll see that it is simple. Minus what? 3s plus 1, s plus 3. Actually, I forgot to mention the 7. 7 is there. E to the power of minus s. So, 2 poles, pretty easy to find the value for that, am I right? So I call it K1 over S is gonna be K1 plus K2 e to the power of minus 3t ut, correct? You find this K1, K2 from here. Not challenge. This gonna be this minus, same thing repeated here. When you don't need to calculate K1 and K2 again, just whatever it is. Plus K2 e to the power of minus t u t, am I right? What about this part? It is an exponential part in the frequency domain. It's going to be a shift in the time domain, am I right? It's going to be t minus 1 every t. So if you apply such a pulse to that circuit, this can be the output. If you wanted to use that original approach, actually, remember that transient technique? You could ignore this part, you calculate for a step 5, then you calculate something like this. You calculate something, it was supposed to reach to the 6. You calculate something like this. So you could find this function. Then for the next step, this was the new initial value. Then you calculated, it was something like that. Actually, this is going to be the response. It was possible to calculate that, but this point was important. At this point, you had to find a value, the initial value for the rest, based on the equation you have. At the t, you could put 1, then you could find the value for this. But I didn't solve that. I wanted to practice Laplace. For Laplace, you don't care about this middle initial value or anything else like this. Instead of 2 times solving one problem, in one shot, we solve it. This equation, when you plot it, is going to be something like this. You have a question?
Can you please also explain how you get 4V naught up there?
What is the current in this branch and in this resistor?
V naught. V0.
V0, V0. So, do you agree that this current is going to be the same current here as well? The current here is V0 as well, am I right?
Yeah.
So, what is the voltage here if you do a start from here to go? It's going to be 4 ohm multiplied with the current which is V0. or V naught. That's the voltage of that node. Correct?
Yeah,
And based on that, I written this base here.
I got that.
Got it? Everybody solve like this? Any question? What is beautiful about the next?
No initial conditions again,
Why?
cause it's AC.
It's steady state.
Correct. This is AC, then we transfer it to the Laplace. We don't care about initial values. Then this gonna be actually 2 over S. This was S, this is 2, 1, this is 2I, 2IS this time. 2I1S, this is I. 1S we are looking for, and this is IO. This is 4S over S2 plus 4, 2 to the power of. Agree? So I have to write 2K here. I have this dependent source which I need to take care, but we are lucky here. This one, actually, the current of this loop. But this gonna be I1, this gonna be, I call it I4. I will write 2 KVL, and from those KVL, I find I0. It's gonna be what? Plus 1 by I1, actually, with this impedance together, is gonna be 1 plus 2 over S by I1 minus 4S over S2 plus 4. Coming to this one is gonna be plus S I1 minus IO. Done. The second one is gonna be S, so let's say plus S IO, this time minus I1 minus 2I1 plus 2IO equals 0. We have two equations here. Two unknown parameters. We are looking for I1. No, IO. So it's not gonna be difficult here. From here we find I1, put it in this one. So it's gonna be
I1 ends up equaling I0.
to make sure this is 0, this is 2 minus 2, definitely there is one way. I1 equals IO. But there is no other way that you can make this 0. This condition gonna be valid, this condition gonna be valid too. Okay, then in this equation, I1 everywhere I put I0. So beautiful, this gets 0. Then IO is gonna be 4S over S2 plus 4 divided by 1 plus 2 over S. Agree? I multiply everything by S. This is gonna be S2. This is gonna be S, and this is gonna be 2. This S2 plus 4, also I take it, put it down. I can move it over here. This is 1/4 and it can be S2 plus this kind of we have 3 poles. Now you have to find these 2 poles. So
Question. For the cosine, I think that should be square root of 2 instead of 4 in the denominator.
It's 2 squared, so it's 4.
Oh, I'm stupid.
two is good. This gonna be K1 over S plus 2 plus K2 over S plus 2J plus K2 conjugated S minus 2J. You find. You know that when you calculate this part, the cosine with the same frequency as the input frequency gonna be generated. Because the circuit cannot change the frequency. Damp it, amplify it, but not change the frequency. Ah. Now some simple questions. Mesh matrix. Big Ohm's law. How many loops I have? 4. Everything is voltage, no dependence. There is no simpler question. So it is 4 by 4. I will write it here. It can be 1, 2, 3, 4. Mesh is going to be I1, I2, I3, I4. And equals to something. I make this part 1, 2, 3, 4, divide it to avoid confusion, okay? Make it easier for you. In loop 1, what should I put here? 1 by 1. Sum of the impedance, sum of the resistance in the loop 1. R1 plus R2 plus R4 plus R6. For the second loop, 2 by 2. So it's going to be R4 plus R2 plus R5. For the third one, R6 plus R8 plus R7. For the last one, R8 plus R5 plus R3. One, two, this one. Between loop 1 and loop 2, only R4 minus negative R4. Because we know that it's everything symmetrical, minus R4. 1, 3. 1, 3. Minus R6. R6. Symmetrical minus R. 1, 4.
Symmetric, it's pure
3. 2, 3 is 0. That's right. 2, 4. And 3, 4. Or 8. Voltage of loop 1. Consider the direction of the loop. It was what? It was negative V1 if we write the KVL. But right now we want to put that negative V1 other side of the equation. It's gonna be plus V1. For the second loop, it is positive something V1, this is gonna be negative. For the third loop, it is negative, it's gonna be plus V3, and for the last one, it is negative V2, it's gonna be plus V2, plus V4, which is gonna be negative. So, it is solvable, very easy, am I right? Six.
I got it all right.
We want to use nodal matrix for finding VO. There is 2 nodes here. So nodal technique is an efficient approach. So we need to transfer the circuit to the Laplace domain. What is the initial values? Because of UT. So this is gonna be 3 over S. This is 2S. This is gonna be half. It's gonna be 2 over S. This is gonna be 1. 10 over S, and this is 2. This node, we call it VO. This node, we call it V1. In the nodal technique, the target is to find the voltage of the node. So, one thing we need to do is still here. What is that? Is it ready for nodal matrix, Garcia? Why?
The voltage,
We don't like it here. This one and this one together are Hebnan equivalent. Convert it to the north. So if we convert it to the north one, this is gonna be 10 over S in parallel, consider the same direction. 10 over S voltage over the impedance, 2 over S, the result is 5. Now it is ready. It is a 2 by 2, 1, 2, 1, 2. I put some line here to make it clear. What should I write here? What should I write here?
Middle one?
What?
In the middle one, V1 and V0.
V1, VO. I kept it VO because eventually I need to calculate VO. So, now, what should I write here, Jake?
where you.
Definition, just say definition.
The, admittance of all of the, loads connected.
Admittance, if it was resistive conductance, 1 over Z impedance. Okay, go ahead.
That would be 1 over 2s.
1 over 2S
Plus 1.
plus 1 over 1 ohm. Let's write it here. 1 ohm. For this one, Garcia, what should I write? Look here, on there.
1 over 1 plus 1 over 2s plus 1 over
writing for this one, 1/1 correct, then 1/2s, am I right? 1/2s, not other 1/2s, eventually gonna be s/2, and 1/2. Between them, only one ohm is there, is 1 minus 1/1 ohm. And the current leaving a node is gonna be plus in KCL, so it's gonna be opposite. It is entering the node 1, that 3/s, so it's gonna be negative, because it is here, it's gonna be positive. It's gonna be 3/s, that's the only current connected to there. For the second node, this current there is nothing else, which is gonna be again positive 1. Okay, you have to solve this matrix eventually to find the value. It's not gonna be very difficult, but do you want me to calculate, find you out or not? Yes.
I would like it if you solved the matrix.
Okay. So I multiply, this is a matrix of admitance. I will multiply y minus 1 to this equation, then this part gonna be V1, VO, multiplied with the inverse matrix. Inverse matrix is gonna be 1 plus 1/s minus 1 minus 1 s/2 plus 1.5. Agree? Minus 1 by 3/s 5. You don't have any problem so far, am I right? Correct? Now, value for this. This gonna be 1/s multiple s/2 plus 1.5. It's gonna be minus, am I right? Minus, minus, and minus 1. Then this gonna be positive, this gonna be exchange. It's gonna be s/2 plus 1.5, 1 plus 1/s. Agreed? So I can write it down, 1/, this can be multiplied with all these 4 items, just I keep it out. Said it's gonna be s plus s/2 plus 1.5
Oh, what is it?
plus 1.5, just I will come back. And plus 1.5/s minus 1. Yes?
For 1/1, did you forget to, isn't it meant to be 1 plus 1/2s?
Here is correct or not? It's gonna be 2s plus 1 plus half. So it is s/2 plus 1.5.
And then for that one, what happened to the 1/2s?
1 multiply everything by S, it's gonna be S2, multiply with 2S, it's gonna be S2 plus 1 plus S over 4, is this gonna be plus 3 over 4, I made a mistake.
Would it be easier if?
No, forget this part too, just.
Yeah, in that part, if you just multiplied everything by 2, so you could get rid of the denominator and make them all have a common denominator, so I think multiply it out.
Something like this. Okay, I confused, let me read it again. Because this with this and this, then this with this and this is gonna be S over 2 plus 1.5, or let's say 3 over 2. Then plus this one is gonna be 1 over 4. This one with this one is gonna be 3 over 4s. Plus minus 1. So I must get everything with 2s. This is gonna be s2. This 2 is gonna be 3s. And this is gonna be 2s over 2. For this one is gonna be s gonna be cancelled, it's gonna be 2, this one gonna be 2s. So the result is gonna be this one and this one is gonna be s, it's gonna be s, 2 of them cancel with this one, s plus s over is 3 over 2s plus 3 over 2 done. This is the simple result of this function, okay? And I can repeat it, s over 2 plus 3 over 2, 1 plus 1 over 2s, and it is 3 over s 5. So far everything is clear?
Is that
Xander?
3s over 2s in the denominator?
It's just meant to be 3s over 2.
Which part?
Underneath
one?
no sir, right to the left underneath the 2s, the middle term, is that a 3s over 2s?
Oh, there is no s. 3s over 2, thank you. So, the result is this function 2s over s2 plus 3s over 2 plus 3 over 2 multiplied with, what's gonna be the result of this? We multiply this one with this one with this, and add them. Then we repeat the same thing with this one. Multiply this one with this, and multiply this one with this, and add them. So the result gonna be s over 2 plus 3 over 2 multiplied with 3 over s plus 1 by 5. Correct? The second one is gonna be 1 by 3 over s plus 1 plus 1 over 2s by 5. Kelvin. What is BO? because it has a 2x1 matrix, whatever we see here equals to this one and this one. Considering this gonna be multiple with this one and this one as well. We don't care about V1, am I right? What is VO? S is this term. Multiple with this value. This is our V out, which is gonna be 3 over S plus 5 plus 5 over 2S. Done. You have to a little bit simplify this. So there's gonna be maybe 2 poles here.
Dr.
Sorry.
Mitchell,
Yes. Hey, how are you? Your class?
what time is it?
2 p.m., 3 p.m. I'm kidding.
Here?
You're finished.
Oh, okay, okay.
When your class gonna be started?
11:15, so I'm early.
Oh, okay, that's good. You can come and for preparation. You can.
You mean just
don't
sit
worry.
there? I'll
Yeah.
s-
Anything you want.
Okay, yeah,
Don't
I'll
worry,
just sit back
come.
there.
Okay, perfect. So, just simplify and find the out. Make sense? Okay. Only 2 questions left. Xander, did you address what you want?
Yes, sir.
Okay. Any question, Ethan? Andrew, Ethan, everything is okay? Practice. Okay, question 7. Did I miss anything? No. Okay. First step, Mary. First step. Convert the circuit. Correct. Then, what is the next important thing in transferring to the Laplace? Andrew, don't look there, just here. I wanna transfer this circuit to the Laplace. What should I do first?
Initial condition,
Perfect. What is the initial value?
0,
Why?
because it's a unit step.
Where is that unit step?
Never mind, leave that.
Because it is a steady state, cosine of state. Then, initial value 0, this is gonna be S, this is gonna be 1 over S, 1, 1, 1. This is gonna be 8S over S2 plus 4 2 by 2. The same thing is gonna be 4S over S2 plus 4. This is over IOS. It is 2 IOS. It is said that mesh matrix. Am I right? So then I'm gonna have 4 loops. I said I1. Let's say I2, I3, I4. Everything is a voltage source, perfect, no changes, nothing. We have only what? That dependent source. So let's write it down. One, two, three, four, one, four. So I divide it to make it easier to follow. Then what should I write here? What should I write here?
I'm 119 with 394.
Now we can take care of that control parameter. How? Mary? Control parameter. Because it's a problem right now. There is IO. We don't like it, that IO there. It is IO used here. I don't want write extra unknown parameter, add extra unknown parameter in my equation. Can I convert that IO to something like, something based on I1 to I4? Yes? You see, this is IO. There is a current coming here, which is I1, alright? The same loop, there is another current going this way, which is I2. Then IO equals to what? IO is the direction of I1. I said I1 minus I2. Correct? Now I can use it there. 2 by I1 minus I2. Now it's perfect. One by one, what should I write? Here, what should I write here?
Should be S plus S, 2S,
S plus,
1 over S.
oh, I said S plus. This is loop 1 is here.
Oh, my bad.
1 over S plus 1. Andrew. What should I write here? 2 by 2. This is loop 2.
1 plus 1.
Eton. Eton, the next one. 3 by 3, correct.
3, that's it.
This is
1 over
3.
Yeah. 1 over S plus S.
S plus 1 over S. Perfect. Shane, the last one. What should I write? This is the last loop.
That would just be 1.
1. Chase, 1 by 2. What should I write here?
1. Negative 1.
Negative 1. Because it's symmetrical, I put it here. 1 by 3. I forgot your name, the cameraman.
Oh, Dalton.
What was your just no?
Sir?
Your name?
Dalton.
Dalton, sorry.
No, you're good. Let's see. 1 and 3. 1 over S. Negative 1 over S.
Negative 1 over S. And I put it here. Next is rayon. 1 by 4. 1 by 4. What is the mutual
0.
0, 0, 2 by 3, Justin. 2 by 3. Xander, 2 by 4.
0.
2 by 4. There is no mutual resistance. And 3 by 4, Kevin.
Where you at for? Let's see. Where's, oh, I see. It's just 0.
Jeremiah. Voltage in the first loop. What should I write here? This is loop 1. What is the voltage? Sum of the voltage in this loop. What do you see?
8S over S.
Plus or minus?
Plus.
Because
It's going from the negative terminal to the positive.
8s over S2 plus 4. Loop 2. Kelvin. In loop 2, what voltage we have?
4S over S2.
Negative or positive?
Negative.
Minus negative 4s over S2 plus 4. Garcia. Third loop. What should I write here?
Would it be 0? 0?
What voltage you see in the third loop? This is the voltage source.
Oh, 2.
Negative or positive?
Negative.
Because it is other side of that. Negative 2.
I want one side 2.
In the last loop, what I see there? Right.
The last loop will be 4s over s squared.
Plus or minus?
Plus.
4s over s2 plus 4 and
Plus the 2i1 minus i2.
plus 2i1 minus I. Nico, you're done?
Well, no, we actually have to bring the I-1s to the
Yeah.
other side, for the 1 and I3, because it's I-1.
We don't like it.
Yeah.
We have to translate it.
It's
Good. Okay.
good. Do I say that?
Step by step. I cannot follow.
For the first one, it's gonna be,
Okay, wait a second. For I1 and I2 in this one, I'm gonna translate. What is the first?
you know that it's gonna be in the third row.
Gonna affect here. If you take the first one,
It's
3I1, then I should put something there. Where?
in the first column.
Here. Everybody realize why I selected this, why she selected this? Because it is a tab, and this is I belong to the first and not the minus 2 goes there, it's gonna be
It's gonna be plus.
plus, let me use red. Plus 2. Then I can take care of this, because I already transferred. For the second one,
It's gonna be, plus I2, so it's gonna go into the second column and it's gonna be negative 2.
it's gonna be that minus 0 is gonna be negative 2 this time. And what left here?
0.
0. Mary, your turn. What should I do with it here?
Your 2 plus
Gonna affect this one, I'm gonna
Mhm.
just say that.
Okay.
This gonna affect the last row. The first item is I1, 2I1. Those other side must affect where?
The first row.
Minus 2. The second one, minus 2I2 here is gonna be plus 2 where?
On the second.
And we are done. Now it's a standard matrix-based equation. You are lucky, there's nothing to ask for. So this is gonna be the end of that. Any question? You stop here because we cannot solve this easily manually. You have to use computer. But this is a standard. This is not symmetrical anymore. It's fine, but it's solvable. But all unknown parameters on one side, the other side are constant. Any question? Easy, am I right? Kind of.
Easier than the node.
Node, you have to, know the difference, duality. This is some of the resistance in a loop, maybe some of the conduct has connected to the node. So repeating that, then there is no difference. Not a big challenge. This one is not a Laplace. Even all help you need is given. Everything is ready.
We have to convert the 5K into an open equation.
Dependent sources are problem, and also that voltage source we don't like it. We use Norton version of that. So when you do this conversion, you should be careful you don't mess up with what? Control parameter. Here everything is fine. Why? Because we don't have any voltage or current from here used in the rest of the circuit. Whatever is there from the rest of the circuit, we don't touch it, used here. That's fine. But if this Vx, if it was defined here, then we had some trouble. Right now it is not the case. So we get rid of this. Instead of that, we put a current source. The value is 3K IX divided by 5K. Agree? That's the value for us. Direction of course, same direction. Now it is ready for nodal technique, but we have to take care of what? Dependent source. For nodal technique, we define the voltage of node. We call it V1, V2, V3, and V4. Yes.
Why did we do that source transformation here?
Why we did what?
Like get the I here?
Because we want to write nodal techniques, the GVI, the nodal matrix we want to write. So for nodal, we don't write voltage source. Because of that, this voltage source says this resistor, we convert it to the Norton version, then it's gonna be a current. Everything is current. Then it is ready for nodal. Okay, what else we need to take care, Jake? It's your turn. What we don't like it here?
The other, we need to put the control parameters in terms of our voltages.
Okay, perfect. For V3, Vx, we should put what?
V3.
It is actually V3. For Ix,
That'd be V1 divided by 6K.
equals to V1 over 6K, perfect. Vx is used here, we call it V3 now. Instead of Ix here, I put V1 over 6K. Which can be simplified. The result here is gonna be V1 over 10K. This is 10 to the power of minus 10 is 1K. Instead of this, I said V3 over 1K. Everything K, the unit gonna be easy. Now, I'm gonna write this. One like this. Next. What should I write here? Aliso, what should I write here? This vector. So, what should I write here? 1 over 4 is wrong. 1 over 4K.
Plus 1 over 6K.
And
1 over 5.
1 over 5. Everybody see that? For 2 by 2, what should I write? 1 over 4K, 1 over 1 over 4K, like 1 over 2K. Agree? The third one is 1 over 2K plus 1 over another 2K. For last one is 1 over 5K plus 1 over 6K. 1 by 2. 1 by 2 is minus 1 over 4K. 1 by 3 is 0, 0, 1 by 4. 5K. 2 by 3. 2 by 3. 2 by 4. 0. 3 by 4, 0. Then here negative V1 over 10K. For this one, negative V3 over 1K. For this one, I made a mistake. It is plus. Entering the negative is going to be plus. This one is leaving is plus, then it's going to be negative. Negative 6 milliamp. And this one plus 6 milliamp. And the leaving one is going to be plus, is going to be negative V1 over 10K. We don't, yes.
Why is the current at that dependent current source V3 over 1K?
Because it was 10 to the power of minus 3, which is
Right.
1 over 1K. multiplied with Vx. Vx is V3. Because Vx is here, it is V3. So we don't like this V1 here, V3 here, and another one, V1 here. So I'm gonna quickly transfer and wrap up the class. This one, I wanna take it to the other side. It is the first row. I'm gonna apply to something here. Alright? Because it is V1 located here is gonna be the first item. First item, I said, it is plus 1 over 10. It's gonna be this value minus 1 over 10. There's no room. And here I put 0. This one, the second row is V3. Second row V3 now affected here. Plus 1 over 1k is gonna be minus 1 over 1k. Then this gonna be 0 here. This one is okay, this one is okay, this one goes again to this row. It is V1 affect the first one. It's gonna be plus 1 over 10k. Remove it here, 0. This is the final function. Here, it was easy. This part of the course was very easy. Thank you. Have a good day.